can you see that these are the same questions? Part A, evaluate the definite integral from 0 to pi of cosine of x dx. And part B, find the area beneath the curve y equals cosine x from x equals 0 to x equal pi. Now I say beneath, but you know that implies that if there's any curve below the x-axis, the area is considered to be negative area. Okay, yeah, these are the same question. We could actually guess the answer to part B. It would help to do a sketch in that guess. So let's go ahead and do a quick sketch of the function y equals cosine x. But let's just draw it from x equals 0 to x equal pi. So we'll just get half a cycle here, half a cycle of cosine x. And here's the positive area above the curve, and here's the negative area below the curve. All right, so positive area above the curve is the same size. It's the same quantity, if we drew this carefully, as the negative area below the curve. So that gives us a really good idea of what's going on here. That implies that the net area is the positive minus the lower, which would give us 0. All right. But we shouldn't guess. Let's not guess. We want to be accurate about that. Let's evaluate the definite integral in part A, and then we'll get an algebraic solution. I mean, our geometric solution is really a guess, essentially, because we can't be really precise. So part A, evaluate the definite integral. Well, since cosine of x is continuous on all real numbers, then the integral from x equals 0 to pi of cosine x dx we know is going to be equal to capital F of x evaluated from 0 to pi. That's that new notation that we learned in our last note. Okay, well, what does that mean? Or in our last comment? Well, it means the fundamental theorem applies. We're going to find the antiderivative, capital F, of little f. What's little f? Little f is the integrand, the function that's being integrated, cosine x. So capital F equals the antiderivative of cosine x. What is that? It's a function whose derivative equals cosine. The answer is sine. All right. Step 2, evaluate the function, the integral, 0 to pi, cosine of x dx. All right, here we go. It's the integral, 0 to pi cosine x dx is equal to, according to the fundamental theorem, capital F of x, which is sine of x, evaluated from 0 to pi, which is equal to the evaluation of sine at the upper limit minus the evaluation of sine at the lower limit. So you see, here's our picture of sine, so we can actually do the evaluation. This is just so I can give you numerical solutions to these. The sine of pi is 0 minus the sine of 0 is also 0. So the answer is 0, just like we guessed. We guessed on part B, because of the geometry, that the net area would be 0. And that's the same as evaluating the definite integral using the fundamental theorem and finding that the evaluation of the antiderivative of the integrand, or the function that's being integrated, the antiderivative evaluated at the upper limit minus the evaluation at the lower limit also gave us 0. So it verified what we were guessing in the first part. So that's awesome. Awesome, awesome. We found a three-way connection here. We found first a connection between the fundamental theorem, part 2, and a connection to finding or evaluating the definite integral of a function. And now it's the same as finding the area under the curve of a function from the lower limit to the upper limit of the integral. So they're all related to each other. So cool.